So it's given the increasing ubiquity of active inference, what do you think is the best way to explain the free energy principle in simple terms that everyone can understand?
Right. And you're not going to answer that. You're going to make me answer that, are you?
Yes, that's right.
I see. Um, right. Well, when asked that question, I normally ask whether you'd like the high road or the low road. And if
Right.
somebody um, requests the low road, I normally start with an intuitive understanding of active influence as something that we do that is predicated on the brain as a predictive machine, a statistical machine, constructing explanations for the sensed world, and would take people through ideas probably traced back to Plato or the students of Plato through Kant, but sort of stopping at Helmholtz and just introducing the notion of unconscious inference, reviewing the notion of perception as a hypothesis testing, and then getting into the weeds in terms of what that means or how that could be implemented in terms of modern day parlance and understanding of neurobiology in terms of predictive processing and particularly predictive coding. So that perhaps the simplest summary of that would be to associate free energy minimization with the minimization of prediction errors, and particularly precision weighted prediction errors. So what's a prediction error? Well, it's simply the difference between what I or my brain would predict I would see or hear or feel if my understanding or hypothesis about the state of affairs out there beyond my brain-bound skull was correct. And if I've got the good or a good enough explanation or hypothesis that allows me to generate predictions of what I would see, then I can compare with those predictions with what I'm actually sensing and use the ensuing mismatch or prediction error to update my hypothesis or my representation of what's going out there. This can be written or understood mathematically as Bayesian belief updating. And I use that phrase simply to segue into the high road, which would be an approach to exactly the same story, but through the lens of physics and the physics of self-organization in particular, that would lead to a Bayesian mechanics that would describe all of my internal self-organization in terms of an inference-like process that effectively minimizes prediction error, where in this instance we're minimizing a variational free energy bound on surprise. So surprise can also have a very technical meaning. In information theory, this is self-information. So I can read the application of the free energy principle to self-organization as a description of self-organization as acting and perceiving to minimize surprise or self-information. And there are a number of ways of, if you like, telling that story. You could stick with the self-information or the surprise aspect and note that in minimizing surprise or self-information, on average over time, I will also be implicitly minimizing the entropy or the dispersion of my states. And that is simply a statement of homeostasis. So we have at hand an interpretation of this free energy minimizing dynamics as a generalized kind of homeostasis, a description of things that persist or that are sustainable. The complement to that, which is mathematically identical, is to reread the free energy as a bound on surprise as the negative free energy, and the negative surprise is just the logarithm of the probability of these sensory exchanges with the world under a generative model of the way in which the sensations were caused. And of course, this is the same generative model that generates the predictions that would be playing a central role in the predictive coding account. Why is that a nice interpretation? Well, basically, you can also think of this log probability of the sensory evidence at hand, given a particular generative model, namely me, of my lived world, as the Bayesian model evidence, or the evidence in this sensory data for my model, which means that a free energy minimizing process can also be read as an evidence maximizing process. And that's poetically, and I think nicely summarized in terms of self-evidencing. So there are a number of different ways of reading the Bayesian mechanics that inherits from the application of the free energy principle to things, either in terms of self-organization and minimizing the entropy or the dispersion of your states in the spirit of homeostasis and sustainability, or you can look at it in terms of gathering evidence for your models of the world. I should just slip in, I've been talking about self-organization and things like you and me, and clearly one has to really define what is the self, or what is the thing in question, and then we get into the world of the boundaries that enable you to individuate or disambiguate something or some self from nothing or everything else or non-self. And of course that's in our world, that boundary is supplied by a Markov boundary, the minimal Markov blanket that distinguishes me, not only well, it separates me from the rest of the world, but also glues me or joins me and enables a bidirectional exchange with the world.
And I just maybe to add a little bit on that, or to pick your brain about it, it's recently, I think, come to the fore that what really individuates the FEP from a theoretical perspective is the presence of boundaries. So maybe would you maybe want to comment on that idea that the FEP is just like physics in the presence of boundaries? I mean, in some sense, you might even think the way I try to explain it, the free energy principle recently is, consider any closed system over time. What happens is, through diffusion dynamics, the system kind of becomes more homogeneous, mixes together. And I think at least what I've been trying to do intuitively is to tell people, well, what does that look like when you enforce the presence of a boundary? It's this diffusion. And since the system can't mix together, the next best thing, right, is this kind of generalized synchrony or coupling. Do you think that's a good way of thinking about it?
Yeah, no, yeah, I think that's an excellent way of thinking about it, and really draws an important and bright line between the physics of equilibria in closed systems and the physics of non-equilibria or non-equilibrium steady states in open systems. So when we talk about self-organization, we are in the world, which is probably more of a 21st century kind of physics. We're talking about self-organization in systems that are open. So we're not talking about the physics you did at school for closed systems. Another way of looking at that, which is just to sort of paraphrase what you're saying, is that as soon as I can draw a distinction or partition all the states in the universe in a way that distinguishes between the states that are internal to something, a self, and external, and identify the boundary states, which now constitute a third set of states that I can even subpartition into active and sensory states to get this reciprocal bidirectional circular causality into the openness. I now have the opportunity to go beyond just talking about the entropy of the states, say internal to a heat bath. I now can talk about the mutual information and the transfer entropy and the conditional entropies of one set of states in relation to another. And being able to talk about sort of mutual informations tells me now a lot about the phenomenology of this kind of self-organization of open systems that are immersed or embedded in a larger environment. And I think you importantly just mentioned the notion of generalized synchrony or synchronization of chaos, that now we're in a position to talk about things, states on the inside in relation to states on the outside. And interestingly, from a purely dynamical systems perspective, the free energy minimizing solution, which indeed is the only solution should you exist, it can also be associated with what, as you say, a generalized synchrony. And that gives license now, or certainly an intuition as to why you can now read the internal states as holding, in some subpersonal, non-propositional way, Bayesian beliefs about our external states. And that's quite a big move, because normally when you're dealing with information theory, you're normally talking about Shannon information, you're talking about an attribute of a probability distribution over some states or some random variables. But as soon as you move into the world afforded by having a partition between internal and external states, you can now talk about the information internal states possess or hold about external states. This, to my mind, this endows the notion of information, or certainly mutual information, with a much more meaningful and vernacular utility. Is that what you were driving at?
Yes, absolutely. So that's great. So we've made it through the first question.